Now let's talk about the correlation of this cache to programming. So most of the times there will be websites, and in websites our data usually is stored in the database. So what happens is, if we go and fetch data every time from the database, then it becomes a costly affair, because database is usually stored on the hard disk, and hard disks are usually slower than RAM. So what happens is, for programming we say, okay, store the data in the memory for faster access. So here the correlation is, there is a DB, there is a RAM, and RAM is certainly faster than the DB. So here let's say, since cache is limited, so imagine if DB can store 1 terabyte of data, and in RAM we will have kind of 4 GB only. So that is the kind of the correlation that we have. So let's say we assume in programming terminology that we have a cache which can store only 5 items, and for simplicity we will assume those 5 items are just 5 integers. Since cache is limited in size, then let's take this example. So let's say there is a data structure in memory which can store these 5 items, and we can't store more than the 5 items. So if you want to access the items in following sequence, so let's say there are certain items, certain rows from the database that we need to fetch, and this is the sequence of that. So first value that we need, or first item that we need, is 2. So 2 we search in the cache, it is not found, so it is a miss. Go to the database, fetch that value, store in the memory, and start using it. So this is the first procedure. Then we get 5. So 5, it is not there in the cache, we check it here, it is not there, we go to the DB, fetch it, store it here, and then use it. Third, we need a record from DB whose key is 2. So we go and check 2 is there in the memory. So we say, oh, this value is anyways there in the memory, I'll use it from here and I'll proceed. 1, it's a miss, it's not there in the cache. So what we do is fetch it from the DB, store that record in the cache, and then start using it. Same way, if 9 comes, it's a miss case. So if it is a miss, we fetch from the DB, store in this memory, and use it. If 1 comes, 1 is a hit because we find it in the cache, we start using it. 0 comes, we don't find it in the cache, it's a miss case, we fetch from the DB, store in the cache, and so far things are clear, right? This is like, so far we have just built the cache. Now we'll start kind of getting into the real problem of programming, where cache becomes important, and we need to deal with such questions in interviews or in mainly the operating systems. So next value, let's say, comes as 10. Now when 10 comes, there is a challenge. 10 is not there in the cache, we fetch it from the database, but if we want to store 10 in the cache, where do we store is the main question, right? So if we see, if you want to store 10, then 10 has to remove, we have to remove 1 item from the cache to store 10. Now question comes, which one to remove? Shall we remove 2? Shall we remove 5? And there are many strategies, many possible algorithms to decide which one is better to kind of get rid of. And very famous algorithm out of that one is called LRU. Now the concept of LRU is simple, that whatever you have recently used, keep that in the cache. And if you have not used something, so RU stands for recently used, and L is least recently used. That means it was used very back in time, but now it is not accessed. So last used is 10. Before that we used 0, then we used 1, then we used 9. So these 4 are actually recently used. This one is same, so we do not want to do this. This 2 is also recently used. So if you see which item out of these was last used or least recently used. So 5 is an item which was used prior to everything. Rest all have been fresh. So 2 is fresh because it has been used after 5. 9 is fresh, it has been used after 5 and 2. 1 is fresh. So these are the kind of fresh items we can say. So it makes more sense to store that data which is more fresh, which has been recently used. So 5 we have to remove. So 5 needs to go away, and 10 will take that place because 10 is a recent item. So 10 puts that here. This is a most popular interview question where people ask you to implement LRU cache. So LRU stands for least recently used.